Today we're going to talk about direct variation. Now, it sounds complicated, but it really isn't. All right, direct meaning that we're going to have y on one side of the equal sign and x on the other. They're directly across from each other. And variation has the word vary. And if something varies, it changes. And we're going to have the variable k there, which will be what determines the change. So y equals kx is the formula for direct variation. If it's in this equation, the two quantities are a direct variation. Notice that there are no addition or subtraction signs involved in this. So let's check and see if two quantities have direct variation. Y equals 4x. Okay. Y, we have a y here, we have a y here. We have an x here, we have an x here, and we have a value for k. It fits the pattern, so this has direct variation. How about y equals 1/2 x? Again, we have a y here, a y here, x here, x here, and we have a value for k. So this too would be a direct variation. How about y equals x minus 5? Now in this equation, we have a y, and we have an x, and we have a k. There's no value in front of x, so that's automatically means 1. But we also have something else. We also have minus 5. And for it to fit direct variation, direct variation has no addition signs or subtraction signs, so this would not be a direct variation. All right, let's check another one. How about this one? Y minus 3x equals 0. Now, don't think about this a minute before you answer, because if we moved 3x to the other side, y equals 3x plus 0, and simplified that is y equals 3x. Okay, in its present state, y minus 3x equals 0 does not fit the direct variation model, this model. But if we simply move the 3x to the other side and simplify, it does. So this is a direct variation. Okay? So k is called the constant in this model. And something that's constant is always there. It's not going to change. So if you think of this like an input-output table, let's substitute a value for k. Y equals 3x. We'll put a 3 in for k. If we have an input-output table, if x is 1, 3 times 1 is 3. If x is 2, 3 times 2 is 6. If x is -1, 3 times -1 is -3. Now, the x values changed, the y values changed, but the 3, or k, has been constant. It stayed the same. Okay, that's why it's called a constant. Whatever the k is, So in our equation here, whatever the value of k is will also be the slope of that line. And if you recall, slope is the incline of the line. So whatever the k is also the slope. So in the equation y equals 3x, 3, or 3 over 1, is the slope of that equation. So the constant of variation is k, and the slope is k. Now, when you graph that, okay, hold on. When we graph that, look and see what happens. Okay, so we have our grid. All right. If we're going to graph y equals 3x, first thing that we do, all we have to do is plot your point at 0, 0. So right at the origin. Okay? If an equation has direct variation, that can always be your first point. And once you have that point plotted, then use your slope to plot the rest of the line. Okay? You don't have to figure out the slope of the difference of the y's. We have no ordered pairs here. So we could make an xy table, but this is so much easier. Plot at the origin, and now we're going to go rise over run. So up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. And there would be your line. Now, because on a direct variation equation, our first plot will always be 0, 0, you know that in direct variation, the line will always go through the ordered pair 0, 0. Okay? It will always go through the ordered pair 0, 0. So if you look at this line that we just did, is this slope positive or negative? It's positive because we look and see that it's rising. Okay? So we know that it's a positive slope. We also know it's positive because the constant is positive. So we know that it's a positive slope. Okay, now the y-intercept. Y-intercept is where the line will cross the y-axis. Okay, if you remember, this is the y. Where does the line cross the y-axis? It crosses the y-axis at 0, 0. Okay, so the y-intercept is 0. If you look on your outline, you'll see that if the k is less than 0, or if we have a negative slope, let's see what that line will look like. Plot at 0, 0, negative 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1. Okay, that line will have a negative slope. So if k is less than 0, we will have a negative slope. And if k is greater than 0, like we saw over here, we see that we have a positive slope. Okay. All right. Use the given values to write an equation that relates x and y. Okay, at the bottom of your outline, it should say use the given values to write an equation that relates x and y so that they vary directly. And we have when x is 4 and y equals 12. Okay, so our formula, y equals kx. Okay, we will put substitute values. Okay, so 12 equals k4 or 4k. If I want to get k by itself, I'm going to divide by 4, and k equals 3. So we found out what k is. Okay, we found out what k is. So an equation that relates x equals 4 and y equals 12 directly would be y equals 3x. We take the k, we keep it in variable form, and we just substitute for the k. We just substitute for the k. So there would be our equation. Okay, let's try another one. When x equals -1 and y equals -1. Okay, let's start with our equation. Y equals kx. Substitute your values. -1 equals k times -1. And we are going to get k by itself, divide by -1. And k equals 1. So we take our equation and we're just going to put the value in where the k is. So y equals 1x, or just simply y equals x. Okay, now writing a direct variation equation. So to summarize, the variables x and y vary directly. When x equals -3, y equals -30. Write an equation that relates x and y so they vary directly. So we're going to start by using y equals kx. We're going to substitute for x and y. -30 equals k times -3. To isolate k, we're going to divide. -3, -3. Those cancel. That leaves k. And over here, we have 2 negatives. That means it's positive. 10. 10 equals k. Now, we go back to this equation, and we're going to substitute and put 10 where the k is. And there we have our equation. Okay? All right. Now everybody, you're going to try the next one. The next one says, find the value for y when x equals 8. Okay? So we found out that y, substitute k, okay, so we found out that we want x equals 8. So we're going to use y equals 10x. That was our equation from above. And now we're going to we simply put 8 where the x is. So y equals 10 times 8. Y equals 80. So when you substitute for x, y equals 10 times x, and y equals 80. So when we find the value for y, we simply found our equation, substituted for x, and that that led us to find y. Lots of steps, but they're not hard. All right, writing a direct variation model. Let's take a look at the outline. The income at a store varies directly as the advertising budget. When the owners spent $3,000 per month to advertise, their monthly gross income was $120,000. If the owners increased their advertising budget to $5,000 per month, how much gross monthly income can they expect? Okay, so we're going to go back to our model, our equation, and we're going to substitute values. So we know 120,000 equals K times 3,000. We solve for K. K equals 40. Okay, so we know the equation is y equals 40x. Now, we want to know if they increase their budget to 5,000. So we're going to put 5,000 where the x is. So we want to solve for y here. 40 times 5,000, y equals 200,000. So the question says how much gross monthly income can they expect? They could expect $200,000. Now, direct variation, again, our model is y equals kx. We can write this in a different way, and it can mean the same thing. For example, if I wanted to have k by itself, I would divide by x, and I would get y over x equals k. That is also a direct variation. This form right here is called a ratio, okay, because it's a proportion. It's called a ratio. All right, questions now. All right, the problems that we're going to do in lesson 4.5 are on your outline. Please note that number 16, 18, and 20 require a graph.